Hello, you wonderful people. Good to have you back. All right, in this lesson, we're going to deal with common mistakes when solving equations. Okay, I'm going to go through about 10 and with a couple of bonuses, and you may want to take some notes and then how to correct them. And I'm going to have two columns. One is incorrect. He says, no, don't do it. That's wrong. The other one is yes, you got to do what it is, the correct way of doing it. First one, not applying bet mass to both sides of the equation is a typical example that I see it all the time. The students, what they would do is that, okay, well, we have to get rid of this -1. Well, we're going to add 1 to both sides of the equation, but they don't actually do the both sides. They just add to one side. And then the next step is 2x equal to 5, and then they go ahead and solve. Well, that is not correct. So you have to, when you are solving equation, whatever you do to one side, you got to do it to the other side. All right, so the answer or the second step is 2x equal to 6, and then of course you go ahead and solve, and then x equal to 3. So this first step kind of screws up a lot of students. Okay, they forget. They just kind of forget. Whatever you do to one side of the equation, you got to do to the other side. Division, multiplication, addition, or subtraction doesn't really matter. All right, next one. Sign errors when distributing. I see this all the time, and mostly in the kind of a junior grade 9 and 10 students, they do that. So remember, you got to distribute this negative outside of the bracket, and especially when this negative shows up without a number, but there is a number. This number is 1, right? So what is happening is that most students, they say, okay, this is negative x, but then they forget that is -1 times -2. So then they leave the -2 as is, and then they go ahead and solve, which is incorrect. So what you need to do, making sure that you go -1 times x would be -x, then negative times a -2, or -1 times a -2, which is be +2, and then that's equal to 3, and then you go ahead and solve the equation. All right, so this is very common. Make sure you don't do that. All right, next one, the lowest common denominator mistakes. Oh boy, this is so common. This is super common. So 1/2 plus 1/3 as an example. My students, some of them, once in a while, in every semester and every year, they give me some weird answers. So they add the top, they add the bottom, 2/5. Well, we guys know this already, so make sure that you use the lowest common denominator. So the answer to this one, you got to have the lowest common denominator 6, so it would be 3 plus 2, and that's 5/6. And of course, you guys know this. Now, the second part to that is an equation. When you have a fractional or rational equation for the higher grade 10 and 11 and 12. Well, in this case, some students, they forget to multiply every term by the lowest common denominator. So in this case, the lowest common denominator is 12. So here it is. I'm going to multiply the left side by 12, the right side by 12. And once we do that, you're going to go through and multiply the entire, every term has to be multiplied. Okay, most students, they forget to multiply the 2. If it's a fraction, they don't make that mistake, but if it's an integer, they make a mistake. So when you go through that, then you're going to multiply every term, and then once you do that, then you set up the new equation, and then you solve the new equation. But make sure you're distributing that lowest common denominator into the bracket for every single term. All right, next one, expanding binomials incorrectly. I see this all the time. So here it is, a plus b. I call it, the way I've written it is a plus or minus b all squared. Doesn't really matter if it's negative or positive or addition or subtraction of the binomials. But what I see, students, they just say a squared plus or minus b squared. That's what they say. Okay. But remember, you have to expand that. This is a squared plus 2ab plus b squared. The reason is that this thing right here is a plus or minus b times a plus or minus b. There are two binomials being multiplied, okay, because there's power of 2 here, or exponent of 2. So when you do the FOIL, which is the distribution acronym, first, inside, outside, last, and then you will end up getting that, okay? So it is not a squared plus minus b squared by just including the exponent into the bracket for each term. All right, next one, dividing by a variable. Ooh, I see that all the time. So here's an example. X squared is equal to 2x. So some students, they just say, oh, okay, I'm going to get rid of the x's from both sides, divide x in here, divide x by there. Well, when you do this, you get rid of one of the solutions. And in this case, it's a quadratic because the exponent of 2. So you're going to only getting the value of 2. Now, one answer is 2, but not complete answer. This equation has two answers. So the correct way to do this is you have to bring everything to one side and set it equal to 0. And then, of course, you're going to go factor. This is the quadratic equation. Then you use the zero product rule. You get x equal to 0 or x equals to 2. And make sure that you actually find my video on solving quadratic equations using factoring and zero product rule, and that would walk you through everything else for review. All right, so do not divide by a variable when you're dealing with the equation, regardless of it's a quadratic or cubic or any higher power polynomials. All right, next one, number 6, radical laws mix up. I see this all the time. The square root of x squared plus y squared becomes x plus y. For whatever reason, students think that, oh, okay, well, I'm taking the square root of x squared, that's x. I'm taking the square root of y squared, that's y. Well, that's not true, because x squared plus y squared, this entire thing is the radicand of this radical expression. You cannot do what is written right here. So to solve this, there is nothing you can do except leaving it alone. That's what it is. You got to leave it alone. There's nothing you can do about it. This operation is not correct. You do not do that. Now, another one that I see all the time is that a square root of x plus y becomes a square root of x plus a square root of y, as if this entire thing is being separated by this plus sign. It is not true. So the square root of x plus y is a square root of x plus y. That is it. It does not break up. There is no such a law. Okay? Do not use this. This is no. All right, number 7, not dividing every term. Well, in this case, we have this example 2 over 2 plus 3x, sorry, 2 plus 3x over 2. So what happens is that some students, they go like this. 2 divided by 2 is 1, and then 3x. Well, that's not true. All right. So in actuality, this has to be written like this: 2 over 2 plus 3x divided by 2. So 1 plus 3x divided by 2. That is the process that you have to use. You cannot divide only one term of the fraction. You have to divide both of them on top. The numerator, if there's a plus sign or negative sign, is breaking up. If you've got 2 terms, 3 terms, each term has to be on top as a numerator, and then of course you have a single denominator and you expand it this way. So make sure you follow this rule. Okay, number 8, breaking up the denominator. 2 over x plus 3 becomes 2 over x plus 2 over 3. You do not do that. No. There's nothing you can do here. So 2 over x plus 3 is 2 over x plus 3. That's it. You let it be, and then you have to deal with it in whatever form that it shows up, but you do not break it up, okay? X plus 3, all of it, the x plus 3, the entire entity, the binomial is the denominator. You cannot break up the denominator, okay? You can break up the numerator, but not the denominator. See, on top, we broke up the numerator. Yes, we did, but not the denominator. We can't do that with the denominator. So don't do that. Number 9, cubic equations being confused with the quadratic equations. And I see it all the time too. So x cubed equal to 8, and then all of a sudden students, they write x equal to plus or minus 2. Well, not really, because if you put in there -2 to check, you can see this. That's not true. -2 to the exponent 3, that's -8, right? So that is not true. So you make sure you understand that the answer to this one is actually only 2. That's all it is, not plus or minus 2. This is not a quadratic, all right? And you can double check it and you notice that you get -8, not 8, right? So of course that's not true. All right, that's a common mistake. Make sure you don't do that. And then of course, oh, one more thing. Maybe I should put the negative part. What if this one shows up? What do you think that would be? Well, that would be only x equals to -2, not +2. So make sure you know how to do that, okay? So both of these ones are common mistakes. The common mistakes in this one, what I see is no solution. That's what I see. Oh, you got x cubed equal to -8. Well, it can't have a negative number, so no solution. Not true. Not true. Okay, that's not true. It does have an answer, and it is this one, x equal to -2. All right, and number 10, binomial squared expansion incorrectly. We have a radical square root of x minus 1, and then when you include this exponent 2, when you expand it, well, oftentimes the students say, okay, square root of x squared is x, minus 1 squared is plus 1, so and then put it in there. But that's not true. And as we talked about that, we have to expand that. So that would be square root of x minus 1 times the square root of x minus 1 again, and then you go ahead and when you expand that, you get x minus 2 root x plus 1. All right, so there are 10 of them. Okay, 10 common mistakes when solving equations, and included a couple of binomials and radicals as well. So make sure you go through each one of them. Check out the next video on the either any of the reviews or a new lesson either about solving equations or radicals or exponents. All right, until next time, keep at it.